Welcome to the third lecture on refrigeration and air conditioning. In the first two lessons, we have discussed the historical aspects of various refrigeration cycles, refrigerants and compressors. So, in this lesson, let us look at some of the important applications of refrigeration. So, the objectives of this lesson are to introduce applications of refrigeration, particularly in food processing and preservation, in chemical and process industries, and some special applications of refrigeration, and then to introduce the applications of air conditioning in for industrial and for comfort applications. And at the end of the lesson, you should be able to list various applications of refrigeration and air conditioning, list typical conditions required for various food products and processes, and state pertinent issues such as energy efficiency, indoor air quality, etc. Now, before discussing the applications in detail, let us look at the relationship between refrigeration and air conditioning. Normally, they are clubbed together, refrigeration and air conditioning. What is the relationship between them? We club refrigeration and air conditioning because air conditioning is one of the largest users of refrigeration. Refrigeration is required in summer air conditioning for cooling and dehumidification of air. That is the reason why we normally club these two systems together. Refrigerant systems can also be used for winter air conditioning if you are using the refrigerant system as a heat pump. This picture here shows the relationship between refrigeration and air conditioning. You can see that you have the area of refrigeration on one side. So, this is the field of refrigeration and this is the field of air conditioning, and there is a large area of overlapping. This overlapping area is because of cooling and dehumidification. In cooling and dehumidification, one has to cool the air and one has to reduce the moisture content of air. This requires a refrigeration system, and by far, as I said, this is the largest application of refrigeration. So, this is the relationship between, and as I was telling you, you can also use refrigerant systems in this area if you are using refrigerant system as a heat pump. Okay. So, now let us look at applications of refrigeration. Can be grouped into four major areas. The first one is food processing, preservation and distribution, and the second application is chemical and process industries, and the third application is, as I said, some miscellaneous special applications which we will see later, and the fourth application is in the area of comfort air conditioning. These are the four major applications of refrigeration. Now, let us look at the application of refrigeration in food processing, preservation and distribution. In fact, this is one of the classical applications of refrigeration and is one of the most important applications of refrigeration. We know very well that food products can be stored for a longer time if you are keeping them at low temperatures. So, for example, our experience tells us that the food products can be stored for a longer time in winter compared to summer. Similarly, if you are keeping them inside a refrigerator, they can be preserved for a longer time. That means you can do the preservation at low temperatures. This fact is very well known. You can store both live products as well as dead products for a longer time if you are keeping them at low temperatures. Let us see what are the live and dead products. Live products are typically products which can breathe, which undergo the process of respiration. These are just like any living beings, and the examples of live products are fruits, vegetables, etc. And the live products get spoiled because of two reasons. One is because of the bacterial activity, and the second reason is because of enzymatic processing. These are the two main reasons behind the decay of live products like fruits and vegetables. Now, let us look at dead products. Dead products means they do not respire or anything, and products like fish, meat, they come under the category of dead products, and dead products get spoiled because of bacterial activity, and it has been shown that both the bacterial activity as well as enzymatic processing can be reduced at low temperatures. Let me show the effect of temperature on storage life. This table here shows how the storage temperature affects the average useful storage life. You can see that, for example, if you are storing meat at 0 degree centigrade, then the useful storage life is 6 to 10 days. Whereas, if the temperature is 22 degrees centigrade, then you can store it only for 1 day. And if the temperature is 38 degrees centigrade, the storage life is less than a day. So, you can see the dramatic change in storage life with temperature. Similarly, for other products, everywhere you can see that as you are increasing the temperature, the useful storage life is reducing. So this is the principle behind food preservation using refrigeration. One thing you can notice here is that compared to products, normal products in dried form can be stored for a much longer time. For example, meat at 0 degree centigrade, it can be stored for 6 to 10 days, but a dry meat can be stored for more than 1000 days. That means you can store meat in the form of a dry meat for more than 3 years. What is the reason behind this? The reason is like this. The decay depends not only on the temperature, but it also depends upon the presence of water in the form of liquid inside the product. So when there is water, the bacteria become more active. This is what is known as water activity. So in the presence of water plus high temperatures, the decay will be faster. Whereas if there is no water, for example in dried products, the decay will be very, very slow. This is the reason behind the drying of food products and storing them for a long periods. Now let's discuss a very important aspect called cold chain. If you want to preserve food products effectively, you have to maintain what is known as a cold chain. Let's look at a typical cold chain for fresh products. It consists of the following steps. The first step is refrigeration is required for post-harvest treatment. That means as soon as food products, fresh products like fruits and vegetables, as soon as they are harvested, they have to be cooled to remove the heat of harvesting, post-harvest heat. So this is the first step in any cold chain. And the second step, as soon as you remove the post-harvest heat, you have to transport the food products to a food processing plants, and transporting has to be done in a refrigerated truck or a refrigerated vehicle. So this is the second step. The third step, during food processing, you find that most of the food processing processes require refrigeration. So this is the third step in cold chain. And the fourth step is storage of the processed food in large warehouses known as cold storages. And then the fifth step is after you store them in cold storage for a long time, they have to be distributed to the customers. So first you take them from the cold storage and send it to retail supermarkets. And again refrigeration is required in retail supermarket also. So this is the fifth step in a cold chain. And the last step is when the customer buys the food products from the retail supermarket, he will take them and he will store it in his home domestic refrigerator. So this is the last step in typical cold chain. And you have to remember that refrigeration is required throughout the 6 steps. And even if one step is not proper, then the food preservation will not be effective. And similar cold chains can also be thought of for frozen food products. Let me show you a typical refrigeration plant for a cold storage. This shows the photograph of an ammonia based refrigeration plant for a large cold storage. Normally ammonia is one very popular refrigerant used in large cold storages. You may be remembering that in the last 2 classes I mentioned that ammonia is very good for large systems because of its excellent properties, and also because it's inexpensive and easily available. So most of the cold storages use ammonia as the refrigerant, and here what the photograph shows is a large refrigeration plant for a cold storage system. Now let us look at benefits of the cold chain. What are the benefits of a typical cold chain? The cold chain reduces the food spoilage, that's very obvious, and excess crop of fruits or vegetables, you can store them and you can distribute them during the off season, or you can for peak demand, you can store them for peak demand. This is the second advantage of any cold chain, especially for seasonal foods. And the third advantage is you can make these food products available in places where they are not grown. And because thanks to refrigeration, you are able to get apples produced in Australia or in far off countries. So they have to be shipped from that place to our country, which requires refrigeration. So this is another advantage of cold chain. And the fourth advantage of cold chain is you can avoid distress selling by the farmers. That means during the peak season, there are no buyers, there is too much of supply and less demand. So in the absence of cold storages, the farmer has to sell it at throwaway prices. So this can be avoided if you have proper cold storage facilities, so that during the season you store the excess crop and you sell them during off season, so that it's very beneficial to the customer. So the cold chain is very, very important, especially because of the large population growth and reduced land for farming. And typically it is said that in countries like India, about 30% of our farm produce and fruits and vegetables are spoiled because of lack of proper cold storage facilities. So this is very, very important, and realizing this, the government has actually given a lot of benefits for setting up cold storages, etc. Now, what are the conditions required for storage of food products? It's not that all the food products require the same conditions for storage. It's not so. Every product has an optimum storage conditions, and the storage life generally depends on the type of the product stored, the temperature at which product is stored, and the moisture content and humidity inside the cold storage, and air velocity inside the cold storage. So these are the 4 factors. Of course, there is one more factor, that is the initial quality of the food products. So for example, the products which are brought to the cold storage, if they themselves are bad, then you can't guarantee a long storage life. So these are the 5 important factors which decide the storage life of food products. Let me show the photograph of a cold storage. This photograph shows a typical cold storage, and you can see how products are stacked, and they are packed and they are stacked. Typical cold storage looks like this, and you can also use these kind of cold storages for storing many fruits, vegetables, frozen foods, etc. In India, typically storage of potatoes in cold storage is very popular. This shows the typical recommended storage conditions for fruits and vegetables. Shown here are the food products, the storage temperature at which they have to be stored, and the relative humidity, and the maximum recommended storage time, and the storage time for tropical countries. You can see that the storage temperature in general varies between 0 degree centigrade to 20 degree centigrade. I am talking about the storage of fresh products. That means they are not in frozen condition, but they are in the condition in which they are harvested. And you can see that for most of the products, the required relative humidity is quite high. That means you have to maintain very high relative humidity inside the storage space. This is required because if the relative humidity is low, then food products will lose moisture. That means it will lead to weight loss because of drying. So you have to maintain a high relative humidity. Of course, for products like onions and pumpkin, you really don't require very high relative humidity because they have a thick skin and the moisture loss is very less. And you can also see here that the maximum recommended storage time varies anywhere between few days to a few months depending upon the type of the product. And you can also notice that the storage time in general is less in tropical countries compared to cold countries. Now let us look at Let's look at the storage of other food products. Food products such as meat, fish, poultry, they can be stored for longer periods in frozen conditions. The reason behind this is also same as that of a dry product. When you are freezing a food products, you are actually temporarily stopping the water activity, because in frozen condition water will be available in the form of ice, so the water activity is considerably reduced. So the bacterial activity is also reduced, thereby you can increase the storage life of food products. Then food products like dairy products like milk, butter, ice cream, etc., they require refrigeration at various temperature during processing and also during storage. For example, milk, as soon as milk is taken from the cows, they require pre-cooling. That means immediately after a cow is milked, the milk has to be pre-cooled, and then in that pre-cooled condition it will be sent to a dairy plant, a dairy farm, where it has to be heated to 73 degrees centigrade for pasteurization. Then after it has to be cooled to 4 degrees centigrade, and it's stored at 4 degrees centigrade. So you require about 13 to 15 degrees centigrade for pre-cooling and about 4 degrees centigrade for storing milk. Whereas milk products like ice cream and all require much lower temperatures. For example, the optimum or recommended storage temperature for ice cream is about minus 30 degrees centigrade. And other milk products like butter, they require slightly higher temperature. They require about 7 to 10 degrees centigrade. So you can see that different milk products require different temperatures, and a dairy plant which produces all these milk products require refrigeration plants which can provide different temperatures and different conditions. And refrigeration is also required in breweries and all, and also for processing and storage of cold drinks, for fruit juices, for wine, beer, etc. And drinks like wine, beer, etc., refrigeration is required because they involve a process of fermentation, and fermentation is an exothermic process. So heat is released during the making of wine or beer, so that heat has got to be taken out. That's the reason why we require refrigeration in the breweries. Let's look at frozen food storage. As I mentioned earlier, frozen foods can be stored for a longer time compared to fresh foods. This is because of the reduced bacterial activity. And normally freezing should be done rapidly to reduce the ice crystal growth. This is very, very important. That means not only the final temperature is important, but also the rate at which the food products are frozen. You have to rapidly freeze the food products so that the ice crystal growth can be minimized. Now what happens if you freeze it slowly? If you freeze it slowly, the ice crystals inside the food products, they become bigger and they damage the cellular structure of the food products. So to avoid this, we have to freeze food products very fast. So typically any food freezing equipment must provide large refrigeration capacities, so that the moment you bring the products, they can be frozen fast. So let me show some of the, or let me name some of the freezers used in industries for freezing food products. We have what is known as blast freezers using a blast freezing technique, and we have contact freezers, we have immersion freezers, and also known as another one is what is known as individual quick freezing. These are the techniques employed in industries for freezing of food products. Normally, as I was mentioning, you require large refrigeration capacities, as the process has got to be rapid, and sometimes instead of using a refrigeration system, liquid nitrogen or solid carbon dioxide is used for rapid freezing of food products. This is also quite effective. And there is another process of food preservation known as freeze drying. In freeze drying, what is done is you first freeze the food product. That means once you convert all the water in the food product into ice, then you dry the product by sublimation. That means this freeze drying process involves two steps. First freezing the food products, then the process of sublimation, during which all the water stored in the food product in the form of ice will be sublimated. So finally you end up with a dry product devoid of any water. So this is a technique used for producing products like instant coffee, milk powder, etc. And this is very effective technique because the quality of the product will be generally good compared to normal freezing or normal drying. And since this is a costly process, this process is generally used for special applications such as in space or military applications, where weight is a very important factor. So what is done is food products are freeze dried So you have a very light food product, and which can be stored for a longer time, and when the user wants to consume it, all he has to do is he has to add water to the product and then he can consume it. So this is a very popular technique for this kind of special applications. Now, of course, as you know very well, domestic refrigerator, thanks to the development in vapor compression refrigeration technology, domestic refrigeration for food preservation at customer's place has become so popular that it is one of the most important or necessary appliances in any home in all developed countries and also in developing countries. And of late, particularly in developed countries and also in big cities, the supermarket refrigeration has become quite popular. Supermarket refrigeration means, as I was mentioning earlier, food products will be stored in cold storage, and from the cold storage you have to bring them and you have to store them in a supermarket so that customers can buy them. And the supermarkets also require refrigeration, otherwise they get spoiled. So supermarket refrigeration is again a different, you require a different design methodology for supermarket refrigeration, because a large variety of products are stored, and these products require different storage conditions and all. And the refrigeration systems used for supermarket refrigeration have got to be very, very reliable because of the cost of the products stored. So this is actually a challenging job to ensure an efficient, at the same time very reliable system for supermarket refrigeration. I'll just show a typical photograph of a supermarket. So this shows the section of a supermarket with refrigerated display cases and all. You can see that how different products are stored, and all these products are under refrigerated conditions. And refrigeration is also required in areas like remote and rural areas for storing farm produce and for dairy products, etc. And one problem with remote and rural areas is they may not have access to grid power. That means they may not get electricity from the grid. So you have to have systems which don't depend on grid, but which are also reliable. So now let us look at applications of refrigeration in chemical and process industries. It is used for separation and liquefaction of gases in petrochemical industries and refineries. Refrigeration is also required for removal of heat of reaction in various chemical industries. It is required for dehumidification of process air in pharmaceutical industries, and it's also required for recovery of solvents and storage of low boiling liquids in various chemical industries. And let's look at some of the special applications of refrigeration. Refrigeration is required in manufacturing, because in manufacturing cold treatment of metals and precision parts and cutting tools is carried out to improve the dimensional accuracy of the precision parts and to improve the hardness, wear resistance and tool life of various materials and tools. So this is one of the very important application of refrigeration in manufacturing. And refrigeration is also required in medical, as you know. It's required for storage of blood plasma, tissues, vaccines, etc. And it's also required for manufacture and storage of a wide variety of drugs. And sometimes refrigeration is also used for local anesthesia. And in construction, refrigeration is required for two purposes. The first purpose is for during the setting of concrete. The setting of concrete and mixing and setting of concrete is an exothermic reaction. That means heat is released during setting of concrete. Now if you look at huge walls, for example the walls of a dam and all, when they are during setting, lot of heat is released because of the exothermic process, and this heat has to be rejected from the wall. And if the heat rejection is not efficient, what happens is temperature gradients will develop inside the wall, and this will lead to thermal stresses, which will finally lead to cracks. So to avoid the cracks, thick walls require artificial refrigeration techniques. So what is done normally is in large walls of the dams and all, pipes are buried through which either a refrigerant or chilled water flows, which takes the heat of the setting process and keeps the temperature gradients small, so that there won't be any appreciable thermal stress development. So this is one of the applications of refrigeration in construction. And refrigeration is also used sometimes for freezing of wet soil to facilitate excavation. This particularly happens in cold countries where the soil becomes frozen, and if you want to do excavation, you have to freeze it first and then do the excavation. And refrigeration is also required. Sometimes it is also used for desalination of water by freezing. As you know, desalination can be done in two ways. Either you can boil the water and collect the and then condense the water vapor, or the other method is you can freeze the salt water. So when you are freezing the salt water, what happens is the salt doesn't freeze first. So first the water part freezes. So the what you get out of the frozen salt solution is comparatively pure water. So this is one of the methods by which you can do the desalination. And of course, refrigeration is also required in for manufacture of ice cubes, ice flakes, etc. Nowadays, commercial ice makers are available, using which you can produce ice in a wide variety of ways, like in the form of cubes or flakes, etc. And refrigeration is also required in preparation of ice skating rings. For example, in summer season, if you want to have ice skating rings, then using artificial refrigeration you can provide ice skating rings for skating purposes. So what is generally done is refrigeration pipes are buried inside the water, and when the refrigerant system runs, the water freezes and ice is formed, and which can be used for skating purposes. And refrigeration is also required very important application for storage of vaccines in remote and rural areas, like vaccines like polio vaccine, etc. Let me show a photograph of a storage system for vaccines. This is a solar energy based system. Yeah, this picture here shows a solar energy driven refrigerant system for vaccine storage. What we have here is a photovoltaic array. This photovoltaic array converts solar energy into electricity, direct DC current electricity, and this DC current can be used for running a vapor compression refrigerator here. Okay, of course you can also use the DC current for running a thermoelectric refrigerant system, but in this particular schematic a vapor compression refrigerator is used, which is connected to the photovoltaic array here. This is the photovoltaic array, and sometimes solar energy may not be available, or sometimes excess solar energy may be required. So to take care of the variations in solar radiations, we have here a charge controller and also a storage battery. That means a typical photovoltaic driven refrigerant system requires a photovoltaic array, a charge controller and a rechargeable battery plus a refrigeration system. In this particular picture, a vapor compression refrigerant system is used. Of course, you can also use the solar energy directly. Instead of converting it into heat, you can also use it directly and have a vapor absorption refrigerant system. Of course, in general, absorption systems are bulkier compared to vapor compression refrigerant systems. So either a thermoelectric refrigerant system using PV modules or a vapor compression system using PV modules are popular. Of course, nowadays people are also developing absorption systems using solar energy for remote and rural areas. Now let us look at applications of air conditioning. So air conditioning is basically required for two purposes. One, the very important application of air conditioning is in the area of what is known as comfort air conditioning, and the second application of air conditioning is for industrial applications. And what is the purpose of comfort air conditioning? As the name implies, the objective of any comfort air conditioning system is to provide thermal comfort to the occupants. And what is the objective of an industrial air conditioning system. An industrial air conditioning system is required so that you can provide the required conditions for processes to be carried out in an efficient way, or products can be produced in an efficient way. So you have comfort air conditioning and industrial air conditioning. Now let us look at comfort air conditioning. As I was telling, the objective of comfort air conditioning system is to provide thermal comfort. Now how do we define thermal comfort? Thermal comfort may be defined as the state of mind which expresses satisfaction with the surroundings. This is the definition of thermal comfort. And thermal comfort generally depends upon maintaining certain temperatures of a human body. For example, the core of a human body has to be maintained at a temperature of about 37 degrees centigrade. If this temperature varies by even 1 or 2 degrees, then human beings feel very uncomfortable. And if the temperature variation becomes large, then it can become fatal, or it can lead to irreparable damages. Normally, the comfort air conditioning is used to maintain the temperature at about 37 degrees centigrade. So without doing any extra effort, the person can feel comfortable. Now let us look at a little bit of physics behind comfort air conditioning. A human body, for all practical engineering purposes, can be treated as a heat engine. That means a human body consumes food, and the chemical energy stored in the food is converted into heat and work, and the work part is used for certain bodily functions, and the heat part is used for maintaining the human body at a certain temperature level, and whatever excess heat is there has got to be finally rejected to the surroundings. So any living human being will be continuously rejecting heat produced inside the body to the surroundings, and the rate at which heat is rejected depends upon the external conditions. So as I was telling, the conditions of the surroundings affects the temperature of the body, and the basis of the comfort air conditioning system is to maintain the right surroundings so that the human body can reject heat in a comfortable manner. Let us look at comfort conditions. What are the requirements for a typical occupied space so that a person can feel comfortable in the occupied space? Generally, the temperatures, what is known as an operative temperature of the conditioned space, should be between 20 to 26 degrees centigrade, and the humidity or moisture content should be corresponding to a dew point temperature of 2 to 17 degrees centigrade. So you can see that for humidity there is a larger bandwidth. And you also have to maintain certain air motion or certain velocity of air inside the occupied space so that a human being can feel comfortable, and this required air velocity falls in the range of about 0.15 meter per second to about 0.25 meter per second. If the air velocity is too low, human being feels stagnant, and he'll have an uncomfortable feeling, and if the air velocity is very high, then he'll have the problem of drafts. So air velocity also has got to be maintained within a range, and the exact value, I mean what I have given here is a range of values. So the exact value depends upon several factors. For example, it depends upon the type of clothing a person is wearing. For example, if a person is wearing very heavy clothing, then he require lower temperature is required in the conditioned space, and if a person is wearing light clothing, then you can go for a higher temperature in the conditioned spacing. So ultimately the optimum temperature to be maintained depends upon several factors. Another important factor is activity. For example, a person is doing very light activity, then the required temperature will be higher, and if the person is doing very vigorous activity, for example in gyms etc., then you have to maintain low temperature. The reason for this is, of course, when the activity is high, more heat is produced, so more heat has got to be lost from the human body. That means higher amount of heat transfer, which requires higher temperature difference. These aspects will be discussed in detail when we discuss thermal comfort in a later chapter. And depending upon the outside condition, it is not necessary that you always require a refrigerant system for providing thermal comfort. For example, if the outside conditions are very cold and dry, then you require not a refrigerant system but a heating system. You have to heat and humidify the air and then supply that hot and humidified air to the conditioned space, so that the conditioned space can be maintained at the required conditions irrespective of the outside cold and dry conditions. So this is what is known as winter air conditioning. And the other opposite is when the outside condition is very hot and humid. Typically this is the scenario in countries like India and all, where the outside conditions are hot and humid in summer. So you require a refrigeration system which cools and dehumidifies the air and supplies this cold and dehumidified air to the conditioned space, so that you can maintain the required temperatures. So you have a summer air conditioning system and a winter air conditioning system. And if you remember, I was mentioning that refrigeration system, if you are using it for cooling purposes, is required for summer air conditioning, and if you are using a refrigeration system as a heat pump, then you can use it for winter air conditioning system also. That means a single refrigeration system, depending upon the design, can function as an all year air conditioning system, provide cooling and dehumidification in summer and heating and humidification in winter. Now, depending upon the end use, comfort air conditioning systems can be classified as residential air conditioning systems, commercial air conditioning systems, air conditioning systems for hospitals, and mobile air conditioning systems. And the required capacity and what is the type of refrigerant system to be used, and what is the design strategy, what kind of controls are required, all these things depend upon the final application. That means you don't have a unique solution for all these applications. Depending upon the end use, you have to suggest a suitable system. For example, if you have a system which has to cater to a house, then the temperature exact temperature requirement is not there. For example, 1 degree plus or minus 1 degree is okay. Whereas if you are using it for other application where temperature is very critical, then you have to have very good control systems which will maintain the temperature exactly. Whereas in residential air conditioning systems, you may not require such very sophisticated control systems. Also, typically residential air conditioning systems are of low capacity, whereas large commercial air conditioning systems are of very high capacity. And one special case is the case of mobile air conditioning systems. That means air conditioning systems used in cars, trains, aircrafts, etc. Okay, they require a totally different design strategy, because one typical problem with any mobile air conditioning system is the outside conditions may vary continuously. For example, a train is moving from let's say Kashmir to Kanyakumari, then it encounters all kinds of weathers, all kinds of outside conditions as it moves from one place to other place. So whatever be the outside condition, the air conditioning system must maintain the same comfort conditions inside. So irrespective of outside conditions, you have to have the same inside conditions. So this is one peculiar aspect of mobile air conditioning systems. Let me show one typical residence air conditioning system used in residences. This is an room, what is known as a room air conditioner, and if you take it out of the casing, so what you have here, if you recollect, a typical air conditioning system requires a compressor here, and a condenser, and an evaporator coil here, and an expansion valve. So it is nothing but a refrigerant system, and it also uses some accessories such as an evaporator fan and a condenser fan for improving the heat transfer rate and for distributing the air. So this is a typical window type air conditioning systems. Of course, you can also have what is known as a split type of air conditioning system, where the condenser and compressor are separated from the evaporator and the expansion valve. That means you can keep the condensing unit consisting of compressor and the condenser outside the occupied space, whereas this window air conditioner, you have to mount it in a window. And the required capacity, normally the required capacity of any refrigerant system is given a unit called tons of refrigeration system. You might have heard people saying 1.5 ton of refrigeration air conditioning system or 2 ton air conditioning system, etc. What is this ton? This ton is a classical unit of refrigeration capacity, and 1 ton of refrigeration is equivalent to about 3.51 kilowatt of heat. That means if a air conditioning system having a capacity of 1 ton will be able to extract 3.51 kilowatts of heat from the occupied space. This is the meaning of tons. Now let us look at industrial air conditioning systems. The main purpose here, as I mentioned earlier, is to provide the favorable surrounding conditions so that the required processes can be carried out and required products can be produced. Of course, the industrial air conditioning system must also provide at least a partial measure of comfort to the occupants, because typically all industries will have a lot of people working there. So you can't really look at only the product or process point of view. You also have to look at the people. That means the industrial air conditioning system at least provide some amount of comfort to the workers so that they can work efficiently. So these are the two main objectives of any industrial air conditioning system. Now let us look at some of the typical industries which require air conditioning. And as I mentioned, in case of refrigeration, the requirements here vary from industry to industry. That means depending upon what kind of products you are producing or what kind of processes are being carried out, the required conditions will be varying. Some of the examples are textile industries. Textile is one of the oldest users of air conditioning. The yarn used in a textile is very sensitive to temperature and humidity. So if you want to have a very high output, you have to maintain the humidity and temperature within certain limits so that the yarn can move at high speeds without breaking. This is the reason why it was used early in the early days, and how the output was increased using an air conditioning system. And air conditioning is also required in printing presses. In printing presses, what happens is typically, for example, if you look at a color printing press, the ink will be deposited in stages. So, and when the paper moves from one stage to the other stage, the ink has to dry off before it reaches the other stage. For example, let's say that first stage you are depositing red ink, and next stage is black ink. By the time the paper moves from the red ink stage to the black ink stage, the ink has to dry. If it doesn't dry, then there will be problems, and there will be mixing of the colors and all. So you have to again maintain certain humidity so that drying can take place within the required time. So all printing presses require very good air conditioning systems. And also the paper used is sensitive to the humidity. So you have to maintain humidity in certain levels so that the paper can you can prevent the curling of the paper, etc. And as I mentioned already, refrigeration is also required, or air conditioning is also required in manufacturing of several precision parts. And this is particularly so in case of watches, wrist watches, or in case of semiconductor elements and all, where the cleanliness, temperature and humidity are very, very important. For example, if the humidity is not right, and if the people start sweating, and when they handle the parts with sweating hands, then water gets deposited on the parts, which may lead to rusting. Since here the dimensional accuracy is very, very important, you have to prevent any variation in the dimensional accuracy. That means you have to maintain both temperature as well as humidity. And in fact, all electronic industries, semiconductor making industries and other electronic industries, the air conditioning is a very, very critical requirement. And in those industries, in addition to the temperature and humidity, the cleanliness of air is also very, very important. That means there should not be any dust particles or any other solid particulates in the air. So in addition to a good air conditioning system, they also have a variety of filtration equipment which will be filtering air and provides clean air to the conditioned space. Then as I said, semiconductor industries is one of the largest users of air conditioning. And in pharmaceuticals, several pharmaceuticals involve several chemical reactions and all, and they require controlled conditions of temperature and humidity. So when they are being produced and when they are being stored, you require certain temperatures and humidity. In fact, you might have seen on many of the medicine bottles and all, they write that store in a cool and dry place. That means the medicine is sensitive to temperature. You have to store it in a cool place, and it's also sensitive to moisture. That's why they say cool and dry. Then photographic materials. Photographic materials are also very sensitive to moisture and to some extent to temperature also. So again, they require air conditioning. In fact, if you remember, Eastman Kodak is the first company to use air conditioning for storing its photographic products way back in 1900s. And air conditioning is very much required in computer rooms, especially in large computer centers and all. There is a large amount of heat rejection, so which has got to be taken out. So you require an air conditioning system. Also in large computer centers, there will be a lot of heat generation because of people, so which also needs to be taken out. So all computer centers require good air conditioning systems. Also the computer centers require clean air also, because you should not have any dust particles floating around. So typically you have to maintain not only the temperature and humidity but also the cleanliness of air. Then air conditioning is also required in mines. For example, mines, as you go down, the temperature will increase, so it will be terribly hot underground and inside the mines. And for the workers, they have to do hard work inside the mines. That means they will be rejecting a lot of heat. And outside temperature is very hot, very high, and a lot of heat generation is there. Then if air conditioning is not provided, then the miner will be subjected to what is known as heat stress, and he cannot work properly. So all mines require good air conditioning. And another important requirement is the air conditioning systems for mines have to provide fresh air also. That means ventilation is also important. So you have to again have systems which can provide the right temperature conditions and also the right amount of ventilation inside the mines. And air conditioning is also required in large power plants. In large power plants, inside conditions will be typically hot because the presence of boilers and other equipments, etc. So the workers will be generally under some heat stress. So you have to provide some amount of comfort by way of air conditioning. This is also true in case of say steel industries. Steel industries also inside conditions will be very harsh. So you have to have some kind of an air conditioning system. One problem with large power plants or steel mills, etc., is it is not possible to air conditioning the entire power plant, or you cannot air conditioning an entire steel mill. That's not commercially feasible. So what you have to do, or what is generally done, is they resort to what is known as spot cooling. That means certain areas where the workers are, only those areas are cool and the rest of the areas are not cool. So this is what is known as spot cooling. So by using spot cooling, you can provide some measure of comfort to the workers. Now let us look at one very important aspect of air conditioning, what is known as indoor air quality. We will see in later lectures that an air conditioning system, the energy consumption of an air conditioning system depends upon how much amount of fresh air or how much amount of ventilation that you are providing. So in the olden days, to reduce the energy consumption, what people used to do is they used to reduce the amount of fresh air. That means they used to recirculate the same air again and again so as to reduce the energy consumption. But later it was observed that people who were spending a lot of time in air conditioning buildings were suffering from several problems, and this is known as sick building syndrome. That means people working in air conditioning buildings experience certain sicknesses, and this is known as sick building syndrome. And later they found that not only temperature and humidity and air motion, but also the quality of air that you are supplying to a conditioned space is very, very important. This is even more so in nowadays because people are spending a large part of their lives inside the buildings. It is estimated that about 80% of the time is spent in conditioned space. So if the conditioned space is not clean and the air quality is not good, then people will fall sick. As a result of which, as a separate branch of air conditioning, this indoor air quality, or IAQ, it's called as IAQ, has emerged as a separate branch of air conditioning, and it requires different techniques and all to ensure air quality. So this is one pertinent and important issue of indoor air quality. And as I said, any air conditioning system must provide not only required temperatures and all, but also clean and healthy environments. In the olden days, people were very sure that an air conditioned space provides comfort, but they were not really sure whether it is good for health or not. And subsequent studies have shown that if you don't design an air conditioning system, in fact it can be very unhealthy. So nowadays the emphasis is not only on comfort but also on healthy environment. So this is the area which is dealt with by IAQ, or indoor air quality. As I mentioned, the sick building syndrome is very common in especially in places where the outside air is dirty, and the designer of air conditioning system provides very less ventilation to save energy. So in the materials used, typically the indoor air quality depends on the amount of ventilation that is provided, and what is the quality of outside air or the fresh air that you are supplying, and also the what kind of materials you are using inside the conditioned space. So these three parameters decide whether an environment is healthy or not. And generally any indoor air quality study recommends the required ventilation qualities, and also recommends what kind of materials should be used within the conditioned space, and how to treat the air. The fresh air, outside air itself may be dirty, then you have to treat the air before you supply it to the conditioned space. So all these aspects come under the indoor air quality. Now let us look at another very important issue, that is energy. All air conditioning systems consume a large amount of energy, and now because of the requirements in all industries and in many office places, residences, etc., the installed air conditioning capacity is increasing tremendously, and all these systems require energy, so the energy consumption by the air conditioning systems is also increasing tremendously. And in the olden days, people did not care much for the energy consumption of air conditioning systems. So they were designing the systems without optimizing them. As a result, they were consuming a lot of energy. So nowadays the focus has shifted. Now people say that they want a system which provides not only comfort but which is also energy efficient. So this is second issue of any air conditioning system. So energy efficiency has to be guaranteed by the supplier and by the designer. And the energy efficiency of any air conditioning system depends not only on the air conditioning system but also on other factors. Let us see what are the factors which decide the energy efficiency of an air conditioning system. It depends upon the design of the air conditioned building itself. For example, if the building is not designed to suit properly, then it consumes a lot of energy. And one nowadays you might have seen that a lot of people use a lot of glass. So use of glass actually is will lead to larger loads on air conditioning system. That means you require a bigger air conditioning system, which will ultimately lead to larger energy consumption. So here the architect has a role to play. So the architect along with the air conditioning engineer has to do the complete system design so that the total energy consumption is reduced. And people also use names like intelligent buildings, etc., with reference to the energy consumption. And the second important aspect is selection of suitable refrigerant systems. All refrigerant systems are not equally good for all applications. So you have to, depending upon your requirement, you have to select a suitable refrigerant systems. For example, there are in areas where you have lot of waste heat is available, then it makes sense to select a Vapour absorption system which uses the waste heat and not an electrical energy or mechanical energy. So depending upon the situation, you have to select a required refrigerant system. And the third factor is the selection of suitable indoor conditions. As I mentioned, as I have shown, the optimum indoor temperature varies from anywhere between 20 to 27 or 26 degrees centigrade. And you will see later that if you are trying to maintain lower temperature inside the conditioned space, that will lead to higher energy consumption. That means a lower conditioned space temperature means in general higher energy consumption. So if it is not absolutely required, we must try to keep the temperature on the higher side to reduce the energy consumption. And several factors again come into picture here. For example, you are designing an air conditioning system for summer, and it's a typical office building, let's say, and everybody in the office is wearing very heavy clothing. So as I mentioned, if everybody is wearing heavy clothing like suits, etc., then you have to maintain lower conditioned space temperature so that he can reject the heat. That means lower temperature in the conditioned space and higher energy consumption. And if the same person is wearing light clothing, then you can have a higher temperature in the conditioned space, and thereby you can reduce the energy consumption. So the selection of suitable temperature, this is also very important. Of course, sometimes this can be a psychological aspect also. People may think that lower temperature is better. But it is a job of the air conditioning engineer to convince that it's not necessarily so, and the required comfort temperature is not a single point, but it's a range. And selection of suitable controls. You can also reduce the energy consumption of an air conditioning building by using suitable controls. For example, if you have an air conditioning system which uses a variable speed compressor, so you can reduce the energy consumption using an efficient variable speed compressor. So you require a control which will be able to vary the compressor speed. And then other aspect is the use of thermal energy storage systems. The concept here is like this: there are many places where the night temperature can be very low and the day temperature can be very high. For example, places like deserts, where nights are very cold and days are very hot. So in such cases, you can use the concept of thermal energy storage. That means you can store the cold in the night and you can use the part of it to offset the heating in the daytime. In fact, this is also the reason why old buildings like old temples, forts, etc., they are comfortable even in summer, because there the walls are so thick that they store a lot of thermal energy and thereby they provide comfort even without any artificial air conditioning system. So the thermal energy storage can be provided by way of the walls itself, or you can also have other means of providing thermal energy storage. So these are the ways by which you can control the energy consumption and improve the energy efficiency of an air conditioning system. Now let's conclude this lesson. We have seen that the scope of refrigeration and air conditioning is really very wide and the applications are very diverse. And it has grown tremendously thanks to the efforts of thousands of scientists and engineers over a period of say 100 to 150 years. So it's not the result of a single man's effort, but it's the effort of many people. And right now, as I mentioned, the issues of concern are first is energy efficiency, and second important issue is eco-friendliness. That means the refrigerant systems that you are using should be eco-friendly. They should not create any damage in the environment. These are the important concerns, and people are working on to develop systems which are both eco-friendly as well as energy efficient. Thank you, and based on this lesson I have given some questions. The answers to this will be provided in subsequent lessons. Thank you.